Hello friends, welcome to this another session. Today we are discussing on Amagat experiment. Amagat performed the experiment for number of gases and studied their curves and conclude the experiment. So first of all we have learn about the construction or apparatus of the Amagat's experiment. So this is the circuit figure of Amagat's apparatus for nitrogen gas. This apparatus is set up at the bottom of coal mine. Consists of large cylinder of mercury C. Here. The S is the screw plunger is inserted in it and produce a pressure up to 423 atmosphere. A long strong cylinder of 1000 feet is attached to the cylinder tube C. Used to measure pressure directly. A small accurately calibrated tube closed at the top of contains with a nitrogen gas N2. It is kept at constant temperature by using oil bath surrounding to this nitrogen gas. The volume of the gas is read directly on calibrated tube and its pressure was calibrated from the height of mercury column in the tube here. Now the long steel tube is replaced by other tube containing the gas to be studied, similar to the gas of tube B, that is the nitrogen. The volume of the gas could be read easily due to calibrated tube, whereas its pressure can be measured from the volume of nitrogen in other tube. This is a simple experiment was done by Amagat's experiment. And this experiment is set up at the bottom of coal mine. And now Amagat plot the graph, the PV versus P for different gases, and under this study, first he take the pressure on x-axis in atmosphere and the PV at y-axis for hydrogen gas, for nitrogen gas, and for carbon dioxide. First of all, we are taking the hydrogen gas. Hydrogen class of gases having very low critical temperature. Its isothermal at different temperatures are almost parallel here and become straight line above 100 atmosphere. from this side. The PV increases with pressure. This PV is increases with the pressure, which shows that the hydrogen is less compressible than consider of Boyle's law. Below this pressure, P100 from this side to this 0, 100 to 0, एटमॉस्फेयर मतलब 100 एटमॉस्फेयर के पहले यहाँ पे क्या होता है, द लेस कंप्रेसिबल or decreases gradually, but this is a small nature. Likewise here some decrease is increase, here some below the 100 pressure, atmospheric pressure, the decrease is maximum in carbon dioxide, but in the hydrogen what happens, a small decrease here. So below this pressure P is equal to 100, the atmosphere PV decreases gradually. This is the study of isothermal, and it varies for 70.7 degrees centigrade, 40.4 degrees centigrade, 60.4 degrees centigrade, 81.1 degrees centigrade, and 100.1 degrees. So the nature is same, almost same, and the below the 100 atmospheric pressure, light, or what we say, the decrease is there. That decrease gradually decrease, but it is a less compressible due to the less compressible than other gases or than Boyle's law. Okay, now for the nitrogen gas here, what happens, again considering the below the 100 atmospheric atmosphere, what happens, what is the nature of decrease by increasing the temperatures. Here the first increase in the keeping the constant temperature 17.7 degrees centigrade, and studied the behavior of isothermal. So below the 100 degrees centigrade there is a it reaches to the minimum value, so small decrease is there. So for not nitrogen gas class of gases whose critical temperatures are medium, so here critical temperatures are medium. PV at first decreases at a low temperature, means 71.7 पे यहाँ पे थोड़ा डिक्रीज देता है, यहाँ पे थोड़ा स्टडी करेंगे उसके आगे बार क्या होता है. With increase in pressure reaches a minimum value at a certain pressure and then increases steadily by increasing pressure further. There is a sag, so the sag in curve is more at a low temperature and the sag is no more at the higher temperature. So this is the study of PV for nitrogen gas. Now again study the with कार्बन डाइऑक्साइड. अब ये ऐसा क्लास जिसके अंदर मैक्सिमम डिविएशन आता है, वहाँ पे हमें क्रिटिकल टेम्परेचर से पता चलता है कि उसका लिक्विफिकेशन कितना हो रहा है और नहीं हो रहा है. यहाँ पे दो गैसेस के अंदर क्लासेस के अंदर गैस ऑफ क्लासेस के अंदर क्या हो रहा है कि स्मॉल डिक्रीज है, और दूसरे इसमें नाइट्रोजन में वो मिनिमम थोड़ा जो भी है वो मिनिमम डेविएशन पे जा रहा है. द सैग ऑफ कर्व जो भी है उसका आपको लो टेम्परेचर पे ज़्यादा दिखाई देगा और हाई टेम्परेचर पे कम दिखाई देगा. बट इन द क्लास ऑफ हायर क्रिटिकल टेम्परेचर आर easily liquefied, so this decrease is nothing but the liquefaction of gases is there. So the shape of curve is similar to the nitrogen gas, but sag is much greater. ये जो sag है यहाँ पे आपको ज़्यादा दिखाई देगा comparative to nitrogen. the minimum of all curve here, the minimum of this all curve यहाँ पे हर एक का यहाँ से लेके यहाँ तक का क्या है, फॉल अपॉन अ स्मूथ कर्व। देखिए आप यहाँ पे स्मूथ फॉल है और फिर यहाँ से इस प्रेशर से इंक्रीज हो रहा है, इस प्रेशर से इंक्रीज हो रहा है, यहाँ से यह इस प्रेशर से इंक्रीज हो रहा है, ये यहाँ पे, बट यहाँ पे जो है 100 के करीब अबव द 100 ये चेंज होता है। तो क्या होगा हमारा स्टडी, ये फॉल स्मूथ हम इस डॉटेड लाइन से शो कर रहे हैं विथ अ टर्निंग पॉइंट जो भी है उसका मतलब वहाँ का, यहाँ से यहाँ तक का मतलब लिक्विफिकेशन हो रहा है, बाद में गैस स्टेट में जा। सो एट हाई प्रेशर, देखिए अभी मैं समझो यहाँ का प्रेशर 400 लेता हूँ तो क्या होगा, ऑलमोस्ट सिमिलर आएगा ये, है ना। तो ये ऑलमोस्ट सिमिलर मतलब स्ट्रेट लाइन में जा रहा है वो, एज वी आर इंक्रीजिंग द PV also increase, but the initial there is a small fall and the more sag is here produced. Okay, so at a higher pressure the graphs are straight line with in all these three cases. At very low temperature hydrogen and nitrogen curves are identical, and still low temperature both these gases behaves like a carbon dioxide curve. सो ये तीन कंपेयर करने के बाद अमेगट से कंक्लूजन पे आता है। वो कंक्लूजन क्या है, नो एक्चुअल गैसेस रियली ओबेज द बॉयल्स लॉ एट अ हाई प्रेशर। द डेविएशन फ्रॉम बॉयल्स लॉ इज सिमिलर, sorry in this here is similar is there, but it is a law is similar for all gases, but only different in degrees of deviation depending upon their critical temperature. Deviation from Boyle's law is more in case of easily liquefiable gases. If the temperature of gas is nearer to its critical temperature, then its deviation is more from Boyle's law. This is the conclusion. But some drawbacks of the Amagat's experiment is there. It is not possible to measure very small volume occupied by the gas accurately at high pressure used in the experiment. And also it is not suitable to measure very high pressure by long column of mercury tube. So with this conclusion and drawbacks, we studied the Amagat's experiment. Now the question arises, what is the difference between gas and vapor? Below the critical temperature, the gas is termed as a vapor, and above the critical temperature, it is called a gas. Because after liquefaction, the phase is changed. So this is the Amagat's experiment studied in hydrogen gas, nitrogen gas and carbon dioxide. So we can study the behavior of gases at a high pressure. So thank you very much for watching this video.